Hello and welcome back to CST 2120. So in this lecture I'm going to talk about AJAX. So in previous lectures I've explained what the HTTP protocol is all about, how we can build web services based around HTTP to sort of send and receive data in JSON format. I've also talked about the Node.js library, I guess, that lets us, or application that lets us run JavaScript without a browser. And I've explained how we can build web services using the Node.js Express module. Previous lectures I also used the browser and the Postman to kind of test these web services. And the sort of final piece of this particular puzzle is how we can use JavaScript running in the browser to talk to the server, to talk to the web service and exchange data with that web service. So AJAX stands for Asynchronous JavaScript and XML. So hence the acronym. Originally developed to exchange XML formatted data between JavaScript running in the browser and the server. And there was a sort of time when XML was like wildly popular as a data format. Now people have largely migrated to JSON for most of the stuff that XML used to be used for. And so most web services are based on JSON. And so we're going to, in this lecture and in this course, we're going to be using AJAX to exchange JSON formatted data between client and server. So the idea behind AJAX is that there's a couple of client libraries that I'm going to cover, the XMLHttpRequest as well as the fetch one. And JavaScript can use these libraries to send HTTP requests to the server. Yeah? And so this enables the JavaScript to update the web page without reloading the page from the server. Yeah? So in older models of kind of ways in which older ways of building websites, there's the browser would send a GET request to the server would interact with the database, get a bunch of data. It would wrap that data in HTML tags and return the entire HTML page back to the server, back to the browser, and then the browser would then reload that HTML page into the document object model and so on and so forth, so the user could see it. Yeah. These days, more modern websites, they have JavaScript running in the browser. The JavaScript pings the server, gets a bunch of JSON, and that JSON then is inserted into the page by the JavaScript. That's how that works. Yeah. And the AJAX is the bit that enables the JavaScript to talk to the server and get that data. Yeah. So it's a little bit like the rankings table that we did in Coursework 1, where you have the data in JSON format, and the job of JavaScript is to wrap that in a bunch of table tags and insert it into the page. It's the same basic idea as that. Yeah. So modern websites like, Gmail, Amazon, Facebook, and so on, often use this kind of approach where the JavaScript running in the browser talks to the web service, gets back some JSON and puts it into the page. So in Coursework 2, the architecture looks a bit like this, right? We've got the browser containing a single HTML page. We've got Express running on Node.js, producing the web service, and that's talking to the MongoDB database. Yeah. And this browser and the Express web service are exchanging JSON formatted data, and that's the piece of the puzzle that we're covering in this lecture, yeah? In which we can use JavaScript in the browser on the left here to talk to the server and exchange this JSON formatted data. So in this lecture, I'm going to briefly explain the web service I'm going to use in these examples, because I can't really demonstrate AJAX without a web service running, so I've got this sort of very simple cat web service. Then I'm going to talk about the sort of original library for AJAX, which is the XMLHttpRequest library, or function, whatever you want to call it. Library, class, object, whatever. And then we're going to talk about the more modern one based on promises, which is this sort of fetch method, yeah? Fetch function. And at the end, I'm going to talk about the problem of cross-origin resource sharing and how you may encounter that error when you're writing this kind of code for your projects. Okay, so let's start with the web service. I tend to use cats because they're sort of funny and neutral, you might say. The web service has two methods and paths. We can send a get method, get request to the web service, and we'll get all the cats back in an array, just kind of structures as JSON. And then we can also post to the web service to add a new cat. It's pretty simple, really. If you remember the kind of Express code that we wrote, to build a web service, here's the sort of the cat web service bit of it. So we set up Express to handle post requests to the cats path, and all it does is storing in an array. I'm not using a database in this example. And then if we want to send a GET request to the cats path, then it basically stringifies the array and sends it back. So very, very simple example. Obviously, I'm expecting your coursework to be much more complicated than this, yeah? Okay, so just to remind and refresh what the web service is doing, let's have a quick look at it in Postman. So let's just go to the Get tab. So if I send a GET request to cats and send it, then in this case there's no cats. I've just restarted it for this example. And then if we send a POST request, for example, if I put in the body of the request like name, Ginger, age 15, and send that, then we get some kind of acknowledgement in JSON format. And then we send a GET request again, then we get there's the current set of cats, which is in the case just Ginger. Yeah, so should be obvious. I've gone through this really slowly. This is kind of our web service, and we're sending GET and POST messages to and from that web service. Yeah. Okay. So let's now talk about how JavaScript running in the browser can talk to this web service and get the data. Yeah. And the first method I'm going to cover is the XMLHttpRequest. This is a HTTP client library that, unsurprisingly, lets JavaScript running in the browser send HTTP requests to the server. Yeah, the name is because originally, as I said, XML was a very popular data format. Now we kind of use it more for. Now we use the XMLHttpRequest to exchange JSON formatted data. That's much more common. Yeah. Obviously, we could make up our own data format if we wanted, but JSON's what we're using in this coursework. Yeah. Now, if you remember the lecture on callback and some promises, the XML HTTP is based on callbacks. So what we do is we set up the HTTP request, we send the HTTP message to the server, and then the callback is triggered when we get the response back from the server. That's how that works, yeah? And I'm going to step through the code for each of these methods in some detail. That's kind of really the purpose of this lecture. And I'll also provide the example code as on the course website below the lecture. Yeah? So this little example here, it's just to demonstrate working. So to demonstrate it working, I obviously need to be able to send some data. So I've just put together a very simple input form. It's a couple of input fields, not even a form. And there's a couple of buttons here. One, when I click on load cats, it'll ping the web service and get all the cats back. And then, just like I did in Postman, it's sending a GET request effectively. And add cat will then post the data in this form in a JSON format to the server, where it'll be stored in the array on the server side. Yeah? And this is the initial example, just a console application. So I'm just logging out the data that I'm receiving from the server on the console. So let's just show you it working. So if you remember the Postman example, this is basically the XML HTTP request version of it. I'm just showing you it now, so then we can talk about, and then I'll talk about how it's implemented in a little bit. Yeah. So if I click on load cats, it pings the server and gets back exactly the same string as we did with Postman. And if we add a cat, so that's Ginger. Let's say add Tom, age 5. That'll do. Click on add cats. I get the acknowledgement here, data received kind of thing. If I load the cats again, here you can see I've got the array back containing the 2 cats. And if I did get cats again here, right, you can see here exactly the same thing's happened. I'm getting back the array with the 2 cats. It's just the only difference is that this is Postman, which is, executing it. No idea how Postman does this. There'll be an HTTP client somewhere. Whereas here, this is JavaScript running in the browser that's doing the same thing as Postman. Yeah. Okay, so let's just talk, step through the code to make sure you understand it, and that'll obviously enable you to kind of modify and customize it for your coursework. So this should be really straightforward. You've got the input fields and a couple of event handlers to add a cat and get cats, yeah? So this is where we actually get to the real code that you need to understand in order to make this work, yeah? So firstly, we create a new XML HTTP request, call the constructor of the XML HTTP request. And that gives us the next HTTP object. And then we set up the event, the callback that's triggered when the request has been complete by the server. Yeah. So remember, it's asynchronous in the sense that we send off this request, and at some later point in time, depending on network speeds, server busyness, and so on and so forth, we'll get back a reply. And to handle that in an efficient way, what happens is that the JavaScript, the browser, will then call a function that we set up when that response is received. We don't just sit around waiting for it to happen. Instead, a callback's triggered at a later point in time that will execute the appropriate code to handle a response from the server. Yeah? Then we can sort of, this XMLHttp on error, if we've got some sort of weird error that we haven't handled elsewhere, then maybe that'll trigger. I've never actually got that to work very well, but you know, that happens sometimes. And then we configure the XMLHttp request with this open method call. And there we set the method, in this case get, and we set the path, like we want in this case to send it to cats because we're working on the same domain as this file's being served up for. Yeah, so it'll be like localhost 8080, you know, / whatever, XMLHttp example.html. And then also on that same domain, we'll have the various paths like cats and so on, where the web service is operating. Yeah. And then with get, we don't need to provide any message body. So we just call the send, and then that will send a get request to cats. And then when the response is received, it'll trigger this callback, this anonymous callback function. And what this will do is it'll check the status. So if something's gone wrong, if there's like a 400 error, the server's, you know, sends back some kind of error, doesn't recognize the path, whatever it is, then we're just logging out the error here. Obviously, we want to feed back to user if we did a full application here. And then if it's all worked nicely, we're just logging out the response that comes back from the server. That's all this code is doing, yeah? And so when this is, you know, up and running, it's all working, here you can see the logs of the JSON received back from the server. You know, as we've added a cat, we're getting, you know, as we add cats, we get more cats back when we send get requests to get the cats. A post is very similar with a couple of important differences. Obviously, at the beginning, we need to extract the data from the form. So if you remember, we've got a form here, pointing cuts at me. There's a form here on the left, yeah? So we need to get that data out of the form. Then we need to convert that into JSON, yeah? So a JavaScript object is a data structure in the memory of the computer. We can't send that or receive over the network, right? We need a string, in this case a JSON, and that's where JSON comes in. So we do JSON.stringify to convert that data into a JSON string as opposed to a JavaScript object. And that JSON string we can send over a network. Then we create a new XMLHttp request, same as before. Set up the callback handler, which will come back later. Then we set up a little bit of error handling. And same here, when we open the connection, we're not sending it, we're just setting it up really. But we're choosing the method, in this case post, and we're setting the path, in this case cats. Yeah? Now, the crucial thing you need to do with post is specify the content type of the message. Yeah, we can send, there's a few content types. There's like plain text, we can do form data, we have a series of, you know, like name equals Bob, age equals 5, you know, this kind of equals with the ampersand sort of separator kind of thing. That's form, we can do form data. And I think there's a few other data formats that I'm less familiar with. Yeah, it's probably XML you can probably send. But in this case, we need to put a header in the XML, in the HTTP request, specifying that what's the contents of the body are JSON formatted, and then on the server side, Express will find it easy to extract the data in JSON format. Yeah, so we need to set the request header, otherwise, you know, things will break because we're sending JSON formatted data. And then we do xhttp.send, passing in that string containing the data that we, you know, extracted from the input fields. Yeah. So if you remember, when we go back to the get, here send is empty. It's empty, right? If you look here, we're not sending anything there. But when we come to post and we send, we have to specify the data that we want to be copied into the body of the HTTP message. Yeah, and that's why cat JSON that is being sent there to the server. Yeah. At a later point in time, we don't know quite how long, the server will respond, and then the browser, through the HTTP object, will call the callback function when the server responds. And then we can handle that by checking that there isn't some kind of error status code, HTTP status code being set. That's what we're checking for there. 200 means everything's all fine. And if everything's worked, we'll get back you know, some text, maybe with some information about what's happened, and it'll be set, the status code will be set to 200. Yeah. And in this case, here we've got name data received, not very particularly well implemented in my web service, but it'll do, yeah. So here we're getting back some, we should basically get back some message saying that things have worked okay, yeah. Okay, so that's the very basic version, yeah, and I've sort of shown you it working. I'll show you again in a sec, yeah. And here we're kind of logging all the JSON data out to the console just so we can see what's going on and make sure and explain the basics of XML/HTTP request. But obviously that's not really very user-friendly, right? You know, the users don't want to like do their shopping by looking at JSON strings in the console, right? what we'd usually do is we'd convert the JSON into a JavaScript object and then insert that data into the page. That's just like we did with the rankings table in coursework 1, yeah? So what we want to do that is I've written a separate function here called load cat data. I'm passing the JSON string in here, the XMLHttp response text. And here's my kind of load cat data. I'm passing that JSON string in there. Now it's a JSON string. It's not a JavaScript object, so we need to convert it into a JavaScript object using the JSON.parse method. Yeah. Then we can, just like the rankings table, we can then build a string that has the HTML, that basically wrap that data back that we've received from the server in some HTML tags. So that's what I'm doing there. And then, I've just got a cat div with the ID cat div. And then we're using the query selector to pick out that from the document object model and insert that HTML string that we built there into the page. Yeah? So that's kind of what we want to do, to make it into a real website rather than just some kind of console application. So here you can see I've inserted, all the cat data, Ginger and Bob, into a little table below my input fields and buttons. Okay, well, let's do a little demo, yeah? Can't beat a demo, right? So this is the basic example, right? When I kind of load cats. Sorry, that's not the basic example. That's the basic example. So here we're just pinging the web service and we add cats, Andrew or something, age 6. So this is the console version where we're just logging out. You see here the JSON string here, yeah? And then all we're doing with this example is when we click load cats, it's still getting the JSON string back from the server, but then we're wrapping it in converting it to a JavaScript object, wrapping it in HTML tags, and then inserting it into the page here so we can actually see it. Yeah. So now this is much more like a proper kind of cat website where I could, for example, add a search button and ping the search path on the web service and return the search results. Like if I was searching for products, I could then, or search for, blogs or something like that in coursework 2. I could then see all the search results here, just like a regular website. Now, some of you may be familiar with these kind of frameworks like React, Vue, Angular, and Ember. I'm pretty good on Vue. I don't know much about the other ones. What I've been covering here is how we can load data into the page just using ordinary JavaScript, right? There's no frameworks happening here. We're using just bog standard, what's called vanilla JavaScript, yeah? Just to insert data into the document object model, yeah? Now, this is a simple and a good way to improve your JavaScript skills, right? Get better at arrays, get better at understanding document object model, get better at understanding HTML. This is good practice, okay? And that's one reason why I banned, all these various frameworks for coursework 2, yeah? So modern websites, would typically use Vue or React to load the data into the page, yeah? And how these work roughly is you have a data structure, and you have rules for rendering that data structure into the page. That's certainly how Vue works, yeah? They have like special HTML attributes, and these are used to render parts of the data structure into the page. So when you get the data from the web service, you put it into the data structure, and then Vue will automatically and very rapidly render that data into the page in a very nice way, yeah? So it's obviously a very sensible thing to do. If you're moving on in your professional career to learn one or two of these frameworks and learn how to use them properly, yeah? But I have banned them for coursework 2. One reason, as I said, is that it's better to get, it's very important to get good at writing ordinary JavaScript before you start to use frameworks to make your life easier, yeah? So you need to get the basics done about JavaScript, and really what this module is about getting really good at learning how to write good JavaScript, yeah? And if you get mixed up in trying to learn frameworks on top of that, typically a lot of students get confused with that, yeah? A second reason why I banned them for coursework 2 is before I banned them, on an earlier version of this coursework, I had an awful lot of people handing in like YouTube videos of React because they kind of searched for a single page web application and they got a React tutorial. They didn't really understand what on earth they were doing with it. The JavaScript skills were really poor, and they basically copied the tutorial and handed it in, yeah? And so we got a lot of poor quality submissions based on React without the students really grasping the basics of JavaScript, yeah? So I think it's much more important to grasp the basics of JavaScript in this module, get good at writing JavaScript, and that's why I banned these frameworks. But if you go on to continue studying web development, there's my third year module, there's Luca's third year module. There's plenty of places where you can learn and get better on using these frameworks. And you'll find that having written the JavaScript code yourself to do this, you'll then appreciate what exactly it is that these frameworks do and how well they do it. Yeah. So that's the kind of motivation here, but a bit of context in terms of React, Vue, Angular, and Ember. Okay, so I covered the sort of older library, or class, I suppose, the XMLHttpRequest. Now I'm going to cover the approach for doing the same job but using promises, which is fetch. Yeah. This is a modern method for communicating between JavaScript running in the browser and the server, based on promises. And slightly irritatingly, I've never liked this about fetch. You've got to sort of execute two promises. Yeah, you've got the first promise that sends the HTTP message to the server and gets back a response. Then the second promise extracts the contents of the message from the server. Never quite seen the point of that, but that's how fetch works. Yeah, and you can do fetch. Now fetch is promise-based. And if you remember from the lecture on callbacks and promises, there's two ways of executing promises, yeah? The first way is you can do this then syntax and then do catch and finally kind of all sort of appended as different function calls. And maybe if you love Racket or functional programming languages, that makes sense to you. What I find more intuitive is using this await syntax, where await is used to execute the promise, and then it returns, whatever the promise does, kind of thing, the data that's returned by the call to the web server in this case, yeah? If you want to use await syntax, you must use the async keyword on the functions, yeah? And you can't do await outside of an async function. Just one of the restrictions of that, and you just get used to it after you've had a couple of console errors related to it, yeah? So this is the fetch-based approach. I find it simpler, nicer code than the XMLHttpRequest. So first thing we do is we ping the server, the cat web service, on the path cats, and we're using await here, and then that returns a response, which we can then process and get the data from. Yeah. Now remember, as I said, you can only use await within an async function, otherwise you'll just get a slightly annoying error. So we ping the web service, get the response, and then we can check the response when the fields that's set is okay. Remember the 200 status codes within HTTP. Okay means that the response is, basically the server hasn't replied with some kind of 400 error. And then we can do a second await to get the response, the JSON data out of the response, because that's what we want here. And then we can just log it out. So once we've got it, we can log it out or do whatever we want with it, load it into the page. And with any application, we also have error handling, right? So in this case, we're checking that the response status code is 200, and we'll just log out the status if it's something different. But sometimes the server is just, maybe the server's just down. It's not even responding with any kind of status code. And that kind of error is not going to come up here. We won't pick it up here. Instead, it'll throw an exception. That's what happens with the await syntax. So that an exception means that it'll sort of basically stop executing here if the server's completely down. And we can catch that error here by putting it within a try-catch block. So both of these awaits might throw exceptions right here, probably because the server's down. Here, perhaps because it's not actually JSON formatted data being sent back from the server. And so we should always put that in try-catch block. Otherwise, ultimately your application will just fail if the server's down without any kind of error message going back to the clients. Whereas in this case, we can then insert a message in the page saying cannot reach server, or something useful that the user will help the user understand what's gone wrong. Yeah. Now, just be very careful and clear about which the data type that's returned by these two methods. Yeah. So fetch returns a JavaScript object. Yeah. When I'm kind of doing this response.json, response data is a JavaScript object structure in memory. Yeah. Whereas with XMLHttpRequest, we're getting back a JSON message in JSON format. In both cases, we're sending the same web services working in both cases. It's just these different libraries, have slightly different ways of handling the conversion of JSON to JavaScript objects. Yeah. In the case of fetch, it's done sort of automatically. In the case of XMLHttpRequest, we're getting back the JSON string, and then we have to process that in order to get the JavaScript object. Yeah. So let's just be clear about that. Yeah. So let's just look at my simple example here, load cats. So you can see here, this is basically a string, yeah? We kind of have a JSON string in this case. Excuse me. So we have each of the keys within each of these cat objects is actually got quotation marks around it, and that means it's a JSON string rather than a JavaScript object, yeah? So when I'm logging it out on the console, yeah? As you look at the equivalent fetch example, when we click load cats, instead of getting the sort of string coming out here, we're getting out this kind of data structure here where it's nicely passed by the console into, like, you know, the array structure and telling us an array and so forth, yeah? And it's a prototype array, yeah? So this is a string from XMLHttpRequest, and fetch, when we do the second await, we're getting out the full JavaScript object that we can use straight away in our code. Yeah? All right, so that's the getting using fetch to get stuff. Now I also need to talk about using fetch to send stuff or post stuff to the server. Yeah. So it's nothing revolutionary here. It's basically the same with a couple of bells and whistles. Yeah. So as usual, we need to get the cat data out of the input fields, the name and the age, and we convert it to a string. So we're still converting it to a string to send it to the server. We have to do that, yeah? And then we have the fetch. So the default fetch, if you look at the get one, where it's gone, we don't provide any options here. We just provide the path because it's just sending a get with an empty body, yeah? And with a default content type, whatever it is, yeah? Whereas in this case, we need to specify this, you know, 2 arguments to fetch. First is the path, and the second is the more complicated stuff about headers and the method and the method, which if it's not specified will be a get, yeah? So here we're sending a post, so we need to send a post method. We need to set the content type, application JSON, as I explained with XMLHttpRequest. And here, and so that's the method. We need to set some, we can obviously set other headers if we wanted to. Sometimes you need authentication headers, certain kinds of web services. And here we're providing as the body of the message the JSON string containing the cat data we want to send to the server. Yeah? So it's a little bit different from the XML HTTP request, but kind of the same. Yeah, it's the same in many cases too. Yeah, so that's going to send it to the server. Okay, first step with the various stuff set inside the message, and then we use await to send that to the server and get back a response. And just in the case of get, we then need to extract the response from the server, and then we can log it out or do what we want with it. Yeah. And both of these awaits, I should have put a second one there, can throw errors, can throw exceptions. So we need to put that in a try-catch block so we can handle any errors that will happen there. Yeah. And you should always do that because otherwise random stuff will happen and you won't know what happened where, particularly if different parts of your code are potentially throwing exceptions. Yeah, so Java makes it very sort of rigorous that, you know, a method's declared as throwing an exception and then you have to handle that exception somewhere else. JavaScript's a bit more free and easy, but it will just bail and give you some nasty error on the console if you don't handle it correctly. Yeah. So I think I've kind of demoed that already, but let's just to be super clear, right? I've sort of demoed that one, right? We're loading it and, you know, can add a cat, Ginger, you know, 33 or something. And then we can load the cats and then you can see Ginger 33. So all this example code be online, yeah? And I've kind of got a similar fetch, but with the load method, but with the, where it inserts into the page. Here's basically the same code as here. Just in this case, I'm passing a JavaScript object directly into the code that loads it into the page, rather than passing a JSON string. Okay, well, the final thing I want to talk about in this lecture is cross-origin resource sharing, which often becomes an issue when you're building JavaScript running in the browser, talking to a web service. Yeah, this is a security mechanism that prevents browser code from calling web services that are hosted on different domains. I mentioned this a little bit in the lecture on Express, but I'm just going to reinforce it now because it'll come up almost certainly in your code if you're not careful. Yeah. So we've got JavaScript that's running on the local server, for example, 127 blah blah blah. It can't call a web service that's hosted on a different domain. So this is the domain for the JavaScript code, right? And this is the domain of the web service, yeah? What happens is within the browser, it makes what's called a pre-flight request. It just pings the server to see whether the server will permit the request that it really wants to make. So if I'm running this on localhost, for example, on 127 blah blah blah, using live server, I could run this code on there, for example. And if I'm trying to connect and if I hard code the entire domain on the server, because obviously the web service isn't running here, it's running on localhost 8080. So if I am running my JavaScript code from this domain and trying to connect with a web service on this domain, using get or post, then I'm going to then I'm going to get this error here, right? So if I'm running on the same domain, everything works. Everything that I've shown you so far has been on the same domain. But if I'm running on a different domain, as I said, if my domain name here is 127.1.1, trying to ping a web service at localhost 8080, then you'll get this kind of complicated error, this attempted to fetch blah, blah, blah from origin. That's my original domain, that's here. To connect with that's where it's trying to connect to. The web service is being hosted there. And you'll get this kind of being blocked by CORS policy. Yeah. So whenever you get a CORS policy error, it's almost certainly the reason is that the domain that the JavaScript's being hosted on is different from the domain of the web service. Yeah. So don't use live server with this. It'll just make your life more complicated and harder. Yeah. So you can kind of, I wonder if I can actually demo this. I'm going to go wild and try and demo this. Yeah. So here's my web service, same as ever, right? Let's just load up this fetch example 2 and see if I can go live with that. This may not work, this example, but feeling optimistic. Okay, let's get rid of that. Oh yeah, this won't work actually. Oh, wait a minute, I think it's CORS example. So I need to hard code the entire domain, I think, yeah. So here's my CORS example, yeah. This may not work, but I think it will. So I've got localhost 8080 rather than just cats, because cats doesn't exist on there, yeah. So if I run CORS example, let's just see if I can get it to work, yeah. If it doesn't work, well, never mind, yeah. CORS example. Okay, so there's so this is running on the local domain. If I click on loads cats, yeah, it has worked very nicely. And you get this exact error, right? You're blocked by CORS policy. Whereas if I make this, put this on the same domain, HTTP, this I haven't tried, localhost 8080. Okay, and we try it from the same domain, and then it's worked brilliantly, yeah? So it has to be served up from the same domain and able to be for the browser to talk to the server, to the web service, yeah? Now, there are some fixes for this, because sometimes you want cross-domain kind of sharing of web service and stuff. So there's some headers that the server can set. The most important ones allow access control at origin. That's where the JavaScript's running. And you can also control the methods, and you can also control the headers, yeah? And so the idea is that the browser will ping the server with this pre-flight request, get back these headers, then it'll know that it's okay to talk to the web service, and then it'll then communicate with the web service using JavaScript, yeah? So you can set these headers manually in Express, or there's actually a CORS module that will do this for you, yeah? Now, I tried to do this, I played around with this, but I realized after playing around with it that actually CORS doesn't work with content type set to application JSON, yeah? So you can make CORS work, cross-origin resource sharing work with like form data or text data, possibly with XML, don't know about that. But application JSON, for whatever reason, doesn't work, yeah? There's a hack, right? We can make it form data and say data equals, and then the JSON string, that would work. But setting aside hacks, content type set to application JSON, it doesn't work with CORS, yeah? So, I wouldn't bother trying to make it, hack it or anything like that. Best solution, just serve up your HTML and your JavaScript using Express, right? I've shown you how to do this. The lecture on Express shows you how you can easily serve up static files. So you just put your code in a directory like public or something and do app.use express.static, and then it'll be served up from the same domain, and then everything's nice and easy, yeah? So if you look at my data structure here, I've got public here, and then if I look at my cat web service, I think it is, I'm serving up all my files from express.static set to public here, and then everything will just work. Your life will be easy. Don't make the mistake of using live server, yeah? And just be aware that these cross-origin resource sharing issues are limited to the browser, yeah? Only limited to JavaScript running in the browser, yeah? So Postman's not affected by CORS. HTTP clients running outside the browser are not affected by CORS. So in my third-year module, for example, we're using an HTTP client called Axios running on Node.js to get data from web services. And Axios doesn't care about CORS issues, it will just connect with the web service. So these security limitations that are imposed by CORS are purely to do with kind of browser, JavaScript running in the browser, not for other kind of HTTP clients that you might want to use. Okay, so that's it. So this lecture's co-explained how JavaScript running in the browser can exchange data with a server without reloading the page. So we can use JavaScript in the browser to send get, post, put, delete, and so on and so forth to the server. Two methods I've covered, the XMLHttpRequest based on callbacks, or the fetch method based on promises. Yeah, there's nothing right or wrong about either of these methods. If I had to do lots of these calls in sequence, then I probably wouldn't do that using XMLHttpRequest, because obviously we get this callback hell, we get all these nested callbacks within callbacks, whereas the await syntax is a much nicer way of doing a sequence of these things. If you only need to make a single call to the web service and process the response, it really doesn't matter which one you use. Personally, I like the fetch syntax, and it's good to practice with promises, but you're welcome to use either of them, in whichever way you want. Yeah. As I explained, there is this kind of cross-origin resource sharing restrictions, which will basically make everything fail if you try to use live server, your website, your web page hosted on live server, talking to a server running on, to your web service running on localhost 8080. Yeah? You can just easily avoid these issues by serving up the static files with Express by doing app.use and then specifying the folder name in express.static. Yeah? That's it.